Hello learners, this is Habiba with Excel with me. If you like the video, please do like, share, subscribe and comment below. Let's start today's class, that is power of a statistical test and effect size. In the previous class, we have understood about a power of a statistical test, what is it and what is an effect when we do any research problem. We have understood about these. Why does power matter in statistics also? We have understood with clearly with one example also, along with type 1 and type 2 errors. Now today in this class we are going to discuss about the second part, that is what is a power analysis. When we detect any research effect or something, how we will detect that? Through some power analysis. A calculation that helps you determine a minimum sample size for the study. That means, what is a power analysis? When we do any calculation, it helps you to determine minimum sample size for the study and made up of 4 main components. If you know or have estimates for any 3 of these, you can calculate the 4th component. Let's see what are these 4 main components of this analysis, power analysis. First one is statistical power. Already in the previous class we have understood this statistical power is very important. The likelihood that a test will detect an effect of a certain size, if there is one, usually set at 80% or higher, sometimes 90% also. Sample size, the second component is sample size. The minimum number of observations needed to observe an effect of a certain size with a given power level. The third one, significance level, that is alpha test we do, the maximum risk of rejecting a true null hypothesis that we are willing to take, usually set at 5%. Now the fourth component, expected effect size, a standardized way of expressing the magnitude of an expected result of our study, usually based on similar studies or a pilot study. So these are the 4 components. The first one is statistical power, that is the likelihood of that a test will be detected with an effect with the 80% or higher. Then sample size, minimum number of observations we take, what is the effect of that sample size with the given power level we test. Then significance level, that is we are checking whether there is any effect is there, a true effect is there or not. We accept the hypothesis. Hypothesis testing is done and then significance level is checked, usually set at 5%. Then expected effect size in detail we will understand in the next class. Here, standardized way of expressing the magnitude of expected result of our study, usually based on similar studies or a pilot study. That means we check these effect with others studies. We compare our study with the other studies or pilot studies. Now, before starting a study, we can use a power analysis to calculate the minimum sample size for a desired power level and significance level and an expected effect size. Traditionally, the significance level is set to 5% and the desired power level to 80%. That means we only need to figure out an expected effect size to calculate a sample size from a power analysis. Now, to calculate sample size or perform a power analysis, we can use online tools or statistical software also. Now here, sample size positively related to power obviously. A small sample less than 30 units may only have low power, while a large sample has high power. Now sample size, increasing the sample size enhances power, but only up to a point. When you have a large enough sample, every observation that's added to the sample only marginally increases power. This means that collecting more data will increase the time, costs and efforts of our study without yielding much more benefits here. Now our research design is also related to power and sample size. Let's see how. In a within subjects design, that is each participant is tested in all treatments of a study, so individual differences will not unevenly affect the outcomes of different treatments here. The second one in a between subjects design. Here you might have understood within the subject designs. That means within the individuals we are testing the individual differences here. Here in between subjects design, that is each participant only takes part in a single. So with different participants in each treatment, there is a chance that individual differences can affect the results obviously. Now, within subjects design is more powerful, so fewer participants are needed here. More participants are needed in between subjects design to establish relationships between variables. Now, significance level, let's recapitulate here. The significance level of a study is the type 1 error probability, and it's usually set at 5%. I have shown the table also in the previous class here. This means your findings have to have a less than 5% chance of occurring under the null hypothesis to be considered statistically significant. Now, significance is correlated with power, that is increasing the significance level, example from 5% to 10% increases the power. When you decrease the significance level, your significance test becomes more conservative and less sensitive to detecting true effects. Researchers have to balance the risks of committing type 1 and type 2 errors by considering the amount of risk they are willing to take in making a false positive versus a false negative conclusions. So we will discuss this effect size in the next class. If you like the video, please do like, share, subscribe and comment below. Until then, thanks for your attention and time. Happy learning.